Hello, everybody. I would like to thank you for joining us here today for ABIS webinar on Anonymity of Open Data. We will be talking about how the society can benefit from the potential of big data while still securing privacy and anonymization. My name is Katarina Halushkova, and I'm the communication coordinator at ABIS, the Academy of Business and Society that actually organized this webinar. Today, we will be having two special speakers, Marc Fiammante, the distinguished engineer and leader of the Europe Federal CTO team from IBM, and Paul Francis, the director of Max Planck Institute for Software Systems and the co-founder of Aircloak. This webinar is going to last up to 1 hour. If anybody would like to, there is going to be some time to answer questions. You don't need to wait until the very end of the webinar. You can write them down throughout the whole webinar. Now, without further ado, I would like to give the floor to our first presenter, which is going to be Marc Fiammante. I will just share his screen. And we're ready to go. So over to you, Marc.
Good afternoon. This is Marc Fiammante. I work for IBM in a team that helps European central governments with their solutions and their application. And part of what they're asking for, they are concerned about protecting privacy and making sure that when they release data, it's anonymous, and even that can happen internally in their requirements. So I'll speak of from an architecture point of view and the solutions that are available. While after my talk, there's another presentation from Paul Francis, which will go in more details in the technology and the techniques that are available. So when you look at the open data, it might not be as anonymous as you could think. A good example is the European petition site, where all people European citizens that have submitted a petition would see the name on their site forever. So on the opposite, when you look at the French past judgments, when there's a judgment that can be reused in the future, they replace names by Mr. X or Mrs. Y. So anonymity of that case would be protected. Some cities are publishing sites where you can see the city permits, and they think this is anonymous. But in fact, you can get the address, and then by doing some cross-referencing with a white pages directory, you can quickly find what are the most probable person that submitted a city permit. And I also did an exercise. It's going to a diabetes trial site. I did not put the link to protect that site, in fact, because there were pictures of people on that site with no names, and by doing a Google image search, I could find the names of the persons that were patients that were supposed to be anonymous just by looking for their picture. So the intentions were good and to protect people, but in many cases we are not as protected as we would think. And even with anonymous data, some indirect information about the person can be re-identified, reconnected to the person by looking at other published information. And in Finland, there has been a case where some personal data about cars was released, showing that people from the special forces with their names and which car they had. So there can be unwanted releases of personal data, and so there must be processes to protect that the information, to check that nothing harmful can happen. I've put a link on the Canadian Internet Policy and Public Interest Clinic because they do list all the risk and the and what's related to open data, and it's quite interesting to read that document. So now, when we go specifically into the data, you have personal identifiers, explicit identifiers for a person. It could be your national ID, if there's one in your country, your passport ID, your name, and then you have quasi-identifiers, which are attributes about yourself, information about yourself that could help people narrow down to you. For example, if you live in a small village and you could be the only one in that age range, you know, particularly we have some old villages in France with 30 people. So if you have the address and the age, you can make out who's the person is. And then you have sensitive attributes that particularly when you have medical studies or medication under test or evaluation, you know, the data contains information about the diseases or past diseases that people had or the medical background, and this is quite sensitive. So we need ways of protecting that information. And these are anonymization techniques. And here I'm putting here a list. There will be more in Paul Francis' presentation. If there's one called k-anonymity, which means that whatever information I take from open data, I should be, or data if it's within an enterprise, I should be sure that I cannot differentiate the data from a number of other individuals, K could be 100, so you cannot narrow it down to one person, or you should not be able to have less than a dozen or 100 persons. And so, but even then, if you just create sets, you may not have an even distribution, and so you have techniques to ensure that the data that you produce ensure that you have not groups of 1,000 people and groups of 100. You know that everybody is treated equally. Data perturbation is just you change the data in the data set by another information, that's noise. And I'll show in more detail what that means, which could affect or not if you do statistics. So there are ways, and that was the first technique used in the past, which was mostly to add noise. We also use techniques for masking data, which could keep the nature. For example, if it was supposed to be a geographic coordinate, we could generate other geographic coordinates so that the applications could work, and you could keep the sort orders. So all these kind of techniques are available, but it depends on the need. And then you look at approaches which are more global to the data, or ensuring. One of the problems is when those data sets become bigger, is that those techniques have to be applied across multiple machines or other clouds, and then you need to consolidate, and it becomes a little bit harder. And finally, you need to ensure that even if you're removing someone from the data set, it's the other persons in the data set still are kept anonymous. So perturbation is changing the data. For example, a female is changed to a male. We have masked the IDs and the names. This is I would say, a brute force masking where we've put asterisks, but you could, if the IDs need to respect a pattern, you could have patterns respected. If you could generate random names that respect the capital letters and lowercase and so on. So there are multiple techniques available depending, and you can set policies to do that. But the privacy guarantee, in fact, that was one of the first approaches, was quite weak. Then the second example that I want to bring is the k-anonymity, and it came after the perturbation, and you ensure that information about somebody cannot be differentiated from a set of k individuals, 100, 1000, whatever. So there are many techniques, an algorithm at the bottom. I'm showing some of the ones that we are using, and you end up replacing some of the value by ranges or sets. So if you have relational databases, that might change the type of the columns, or you may have things to do, and the data set will not be equivalent to in the use from the original data set. So this might not be usable in all of the solutions, or it will depend highly on the requirement and the protection that you need. Crowd blending is that you change the personal data by suppressing tuples that are less than, it's a little bit like k-anonymity, but it's more precise, and you also need a bigger data set usually, and you are replacing some of the information also. So as a conclusion, I would say that from what I see and what the requirements that we have, particularly in Europe, privacy is protected, and all published open data is required to be anonymized or protected or grouped, synthesized, so that no one could be de-anonymized. But you have to be careful, because when you're going on social network, and you often consent to have some of your private data being released, and they can use some of the correlations that you put there to find out what you're doing on other sites, for advertisement purposes, or for just when there are elections to reach the people. So the concern is when you combine the open data with other data that you consented to provide to other organizations. And finally, what I want to say, some algorithms are better than others. It's mostly the need and the requirement that will let us choose the best way or algorithm or the purpose. If you want to do, for example, you publish medical research about the effect of a new medication, and some people want to trace back to the real medical case, then you have to do masking with some indexes or pointers that can be reversed only by the people that have the need to know. So depending on the, what is the need, different techniques can be used. And now what I would like is to hand off to Paul Francis that will go into more details in some of the techniques.
First of all, I would like to thank you, Marc, that you gave us this general overview and the comparison of each techniques on the topic of anonymity of open data. I would like to tell our participants that if they have any questions, you can feel free to write it down in the questions section in the panel on your right side. And now I will give the floor to Paul Francis, our second speaker. When you're ready, Paul.
I'm here. Let's see. I have to figure out how to share my screen, right? I see it. I see it. Okay. When ready, show my screen. What happens next? Is my screen showing? I hope not.
Well, now you just make it big so that all the participants can see it in the big overview.
Do you see my screen now?
Yes, I can see it. Yes, but and now I can see it. And now I can see it. Yes.
And it's the one that has the talk?
Yes, it's the one for the practical anonymous data. You just you can just maximize it.
Yeah.
Yes, perfect.
Okay, yeah, I just wasn't sure because I didn't have the opportunity to select which. Never mind,
yes.
Here it is.
Not a problem. So over to you, Paul.
All right, thank you very much. So I'm Paul Francis. As Katerina said, I'm a director at the Max Planck Institute for Software Systems. This is one of, just a little bit about Max Planck, this is one of about 80 some science institutes that exist in Germany that do all kinds of science, physics, chemistry, biology, humanities, legal, and also including computer science. And so I'm working for an institute that's doing computer science. And of course, myself specifically, I'm working in the area of data anonymity. So I'm also a co-founder of a startup called Aircloak. And I work very closely with Aircloak, in fact, because I'm working on an anonymization technology called Diffix. And Aircloak is building and marketing this solution. So for me, it's a very, very good research collaboration because I have a very good engineers implementing my algorithms. Of course, they're helping with the designing of the algorithms. And of course, I also get contact with real users and so on. So it really helps my research. So I would like to first actually talk kind of about terminology. And so the slide I'm showing here, I call the anonymization landscape. Oops, hang on, I don't know why that jumped. The anonymization landscape. And this is, I mean, this does a couple things. One, it does show how, you know, I think there's, hang on a second, I think there's timing associated with that slide, which I don't mean to be. So I just go back here to this mode. Okay, so I mean, one thing that this slide shows a little bit is kind of the difference between how Europe and others, especially in the USA, think about anonymization. And I bring this up in large part, I think, because I've even though I'm an American here, I'm living in Germany, and I've really taken on sort of the European notion of anonymization. So the first thing I want to mention about this is just sort of kind of focusing up on the upper half of this, which is looking at Europe. Of course, everybody by now certainly has heard of GDPR, and GDPR is a lot of regulations that have to do with how to handle personal data or data about actual persons. And GDPR has a sort of a way of getting out of GDPR. So, I mean, essentially they say, look, if data is personal data, then it has to follow the regulations of GDPR, which have to do with how to protect that data, how to encrypt it, how long to keep it, the conditions under which you're allowed to take it, how much you have to inform the users, and all kinds of things. GDPR does not apply to non-personal data. And GDPR says that if personal data is anonymized, then it becomes non-personal data. And so this is a very specific usage of the word anonymized. So, of course, anonymized is a normal word in the English language, and it means a lot of things. I could put a mask on my face, and I might call myself anonymized, right? So you can use this word in many, many, many contexts, of course. But the GDPR has a very specific meaning for this word, which is that if personal data is anonymized enough, then it can be regarded as non-personal data. And if it's non-personal data, then it's not under the regulations of the GDPR, which of course is a fantastic thing if you are handling that data. If you can make your data anonymous, then you don't have to worry about all of these regulations in the GDPR and the potential fines and so on that come from GDPR. So anonymization of data, especially about European subjects, is a very big deal at this point in time. You can well imagine, though, that the GDPR has a fairly high bar for what you might consider to be anonymized and what you might not consider to be anonymized. Exactly what this bar is in some precise terms is actually not defined, but it should be very, very high. And the GDPR says, you should not be able to re-identify or, get back to the identification of the individuals that comprise the anonymized data. And in fact, GDPR has defined another term, which they call pseudonymized. And the reason they define this actually is because often people confuse, well, there's two reasons they define it. One is that often people think that pseudonymized data is actually anonymized data when, by the GDPR, it is not. And also, it is a useful technique, nevertheless, for obscuring data to some extent. And so they do want to encourage people to pseudonymize data if they can, but they still will regard that as personal data. They will not regard that as anonymized. And I'll talk a little bit more about what this means, pseudonymized and anonymized and so on, in the next slides. In terms of the USA, this strong definition of anonymization doesn't exist, and terminology is, in a sense, all over the place. You often hear the phrase de-identified data, which is kind of a general purpose term for various tricks and tools to try to make, and even now I will get into trouble because I want to say try to make data more anonymous. But I will try to use the word anonymous in the strong kind of GDPR sense through this talk. But in any event, in the US, there's often a notion of risk of re-identification. And of course, this always exists in one context or another. But in the context of the GDPR, if you wish to call your data anonymous, then the risk of de-identification should be extreme, or re-identification, sorry, should be extremely low. For all practical purposes, unmeasurable. So I can go to my next slide. Yes. So I'm going to talk a little bit about what pseudonymized is. I mean, basically, it's removing personally identifying information like names and addresses and things like that from the data. But I actually am going to bring up one of Marc's slides in order to talk about this. So this is a slide that Marc had showing how to do k-anonymity. And what he showed here, so if you might remember, he had three designations for this data. One was personally identifying data. And for that, he was looking at the identifier and the name that's shown here. And one was these quasi-identifiers, which is a set of identifiers, any one of which doesn't really identify the individual, but taken together, they may narrow it down to one person. So that was, in this case, gender and country and age. And then he had, disease out here on the side, which he called sensitive information. And if you look at this slide, what you see that that Marc has done with k-anonymity is that he's taken the quasi-identifiers, the gender and the birth and the age, and done something, right, to make it so that in this case there's never one person that has all of these attributes uniquely. So if you look at this, there's two people, males from Italy in a certain age range, and there's two people that are either from England or Israel who happen to be 45, right? But there's at least two people of that sort. And so at least with respect to these columns, the data has been k-anonymized, where k is equal to 2 in this simple example. But really what this data is not anonymized, it's pseudonymized. And the reason it's not anonymized is because of this last column, the disease, right? If you look at the disease, you'll see that here there's one person with a disease A. So in some sense, there's a person here who is identifiable, at least insofar as that they're the only person in this database that has this attribute. So this data would not be regarded by the GDPR as anonymized, it would be regarded as pseudonymized, because you can still single out in some sense individuals. And you might look at them and say, well, all right, there's a guy with disease A, that could be anybody. But of course, if this were really medical data, there would be lots and lots and lots and lots of data about various aspects of the medical treatment itself. When they visited the hospital, what drugs they were prescribed, what specific tests were done, the dates at which they were done, the weight of the person, for instance, when the tests were done. All kinds of information would exist. And certainly, this information is enough to re-identify individuals. And in fact, if you just think about it for a second, if you imagine that you were given a lot of medical data, and you knew that your spouse, for instance, or one of your kids was in this data, you could probably find them, right? There's not that many people, if you know that your wife visited the hospital on these particular days, or you know that she had this disease with that complication or something, just by putting together a little bit of information, you could figure this out. And I mean, this is just, in a sense, common sense, but just to give a specific example, researchers have shown, for instance, that if you have a data set that has geolocation information, so a location where somebody was and a time at which they were there, with 3 or 4 samples of location, you can narrow it down to one person with high probability in the data set. So this example, which is shown here, which is labeled k-anonymity, I would call partial k-anonymity, because it's anonymizing certain columns, but it's not anonymizing other columns. And it's these other columns that would allow re-identification and would require that we consider this to be pseudonymized, at least from a European legal context. All right. So going back to my talk, the current state of practice. So what I'm showing here is, and this is based on my experience working with the startup Aircloak and having many conversations with customers and government people and data protection authorities and so on. Most data that people handle is pseudonymized, and this is for a good reason. It's because pseudonymized data typically has all or nearly all of the analytic power that that raw data would have, that data that's untouched would have. So, as I was just describing, if it was medical data, you would still have all of these medical information. And of course, this is what's interesting about the data, not what the name of the guy is or something like that, but all of the data about medical treatments and diseases and so on. So if it's pseudonymized, you still have very good data to work with. And that's great. And when that's necessary, then that's necessary. And of course, you should do your best to minimize the risk of that data by doing things like removing personally identifying information, or maybe k-anonymizing the personally identifying information. But the rest of the data stays untouched, and And from a European legal point of view, this is pseudonymized data. It's not anonymous data. Of course, sometimes data is anonymized, and I say anonymized here in the GDPR sense. For instance, right, the census bureaus all over the world release data about the surveys that they've done about their populations. And census bureaus, and I'm not going to get into details here on this, it's an extremely long topic, but census bureaus do a variety of things, you know, to ensure that data is anonymous. For instance, they often just sample some of the data and they don't release all of it, or they will just release summary data, summary numbers about areas and so on, or they may take outlying data and remove it from the database, or they may swap data from one person to another person and so on. There's a lot of kind of ad hoc things that they do of this sort, and I kind of list them here a little bit: aggregation, generalization, which is like saying that somebody's in the EU instead of in Germany, removing the outliers, adding noise, which would be perturbation, as Marc talked about, swapping cells around and so on. There's a lot of ad hoc things that can be done, and it's tricky. It typically takes experts, and it takes a lot of thought, and you have to think, well, what is the use case here? What is the valuable information that I want to release? And then decide how many of these techniques that you need to bring to bear to really make the data anonymous as possible. So I guess what's the summary of this slide? The summary is that in practice, most data is pseudonymized, and again, primarily so that it can still be used. And when data is anonymized, it's typically done on a case-by-case basis using a variety of ad hoc techniques, typically by experts, and then with a lot of care taken as to whether the result is still useful and is indeed anonymized. Okay, so I'm going to, I guess I'm going to pick on two things here a little bit. K-anonymity and differential privacy. And I guess now I'm kind of talking as a researcher especially. These are the two techniques that are predominantly studied by computer science researchers. K-anonymity was invented in around 2002, and differential privacy around 2005. And if you look at the computer science literature on this, you'll see that the vast majority of papers talk about one of these two things. And now, in the next comments, I'm going to say I'm going to be talking about GDPR level anonymity. So in terms of k-anonymity, that would mean applying k-anonymity to every column in the database, not just the columns that have quasi-identifiers. And differential privacy, is differential privacy. So the statement I want to make is that these two technologies, when applied in a strong sense, either in differential privacy, there's kind of a measure of noise that can be done, and it's typically based on something called epsilon, on a character called epsilon. Epsilon is a measure of the privacy loss in differential privacy. And if epsilon is set to a level where strong privacy results, or if k-anonymity is used with a high enough k and across all the columns, you will actually end up with essentially unusable data in almost all cases. And I make this rather strong statement, and I probably will regret this, but in a sense to me, and again, this is kind of my personal beef against the academic computer science community, which is focused primarily on these two things. These are kind of the symbols of the failure of computer science to really solve the anonymity problem. The focus on these two things, which are essentially unusable when used in a strong sense. And I should probably change that statement a little bit to say that this is the failure of the computer science community to solve the usability problem. Because in fact, these technologies are very anonymous, but they're not very usable. They tend to destroy the data. And I'm not gonna bring up specific examples of this, but I would like to just point out two technologies that you can go play with yourself if you wish to test this. test this statement. And in fact, you might be quite surprised because you hear about these technologies all the time, and you would naturally think that you could just go off and use them. But there's a tool called ARX, which I strongly recommend you download and try to use. Plug in some data and try k-anonymizing it, or try running differential privacy on it. And our ARX has a differential privacy module as well, and see what you end up with. Or there's a differential privacy tool put together by researchers at Harvard, and I give the URL here. And they have some data sets that you can query through differential privacy, and I encourage you to just go and try it. And in fact, this is easier than downloading our ARX and putting in some data, because the data is already there. And for instance, in the case of the Harvard tool, which I've played with and tried to use, you can literally make 4 or 5 queries. You get reasonable answers with these 4 or 5 queries, but once you've made these queries, you cannot query anymore. You're done, right? And this is to me unusable, right? I mean, anybody who's going to look at data is going to make lots of queries, do lots of exploration, maybe run machine learning and things like this. So I probably get in trouble for this, but if you're really thinking about GDPR level anonymity, then these tools, which are famous and you've certainly heard about, really won't work for you. And again, I encourage you to go try them and see. So what I'm going to talk about for the rest of my slides, and understandably, I guess, is how I'm attacking this as a researcher to try to create something that is, on one hand, strongly anonymous, by GDPR definition, but on the other hand, is useful for analytics. And I won't even go into great detail about the technology of this, but I will talk about it some. So this slide, the anonymization technology is called Diffix, and as I said, it's built and marketed by Aircloak. It provides strong anonymization. Is it perfect? Probably not. Are there possible weaknesses? Probably so. But I will talk a little bit about the approach we take to ensure that as much as possible that's not the case. It does provide useful analytics. So, for instance, if you're counting users, the noise is quite low. It's roughly plus or 5 users of errors. You can make unlimited queries, which sort of sounds like what you'd want to be able to do, but that's not the case with differential privacy. We provide much of SQL, so you can use this system as you would use, almost as you would use any SQL system. And it's doing what we call descriptive analytics at this point in time. I mean, we expect to evolve this, but at the moment it's descriptive analytics. So you can count things, do histograms, heat maps, sums, averages, basic computations like this, as opposed to, for instance, a lot of machine learning techniques and things like that. Those we hope will come later. And it's relatively easy to configure. You don't need to be an expert to use the system. It works with standard data types, so it's not limited to one application or another application. It's really for any use case. And it's reached a reasonable level of maturity. Currently, it's deployed in some banking and telecommunications customers here in Europe. And what I show here, actually, these 2 images, this is actually data taken from the New York City taxi database. The New York City releases information about their taxi rides, actually, every year, and make this open data. And there have been actually this is pseudonymized data. It's not anonymized data, but it doesn't hold any information about the riders of the taxi, just the taxi rides themselves. But even so, people have discovered 1 or 2 small things about this data. For instance, that such and such a movie star took such and such a taxi trip and paid such and such a tip or something. Not really harmful too much, I guess, but nevertheless, it's not as strongly anonymous as they may like. What I show here actually is just a side-by-side comparisons of query that's been done on the raw data. That's the map on the left, and a query that's been done with Aircloak, and that's the map on the right. And actually, what this query is a query that tells the time it takes in general for taxi rides to get from some location to LaGuardia Airport. And LaGuardia Airport is actually this kind of green blob roughly in the middle of the picture. And this is what it is, right? One can talk endlessly about the value of this data and so on, but visually you can just look at this and you can see that not much detail, really if any in this case, has been lost by virtue of running this through diffix, through a strong anonymization. So this is just one of many possible examples of what can be done with our system. Okay, so a little bit about how the system is deployed. So it's what I call query by query anonymization. So it's not that we take some data and run some anonymization over it and then produce new data and then release that data, which is kind of like what you would have seen in the examples before. Rather, it operates on a query by query basis. So you would deploy the system diffix by Aircloak within the secure perimeter of where the raw data, here I call it the backend database. So the backend database here is the raw unanonymized or untouched data. You would put in front of that diffix, and then diffix would interact with the database on a query by query basis. So we expose an SQL interface. An analyst or an application can make SQL queries to our system. Our system will interact with the backend database and then provide an answer which is anonymized. Typically, the answer is an aggregate, because if you really try to ask something about a single individual, you won't get anything back. So just sort of necessarily, you end up with aggregated anonymized answers. So that's how it's deployed. And the technology itself, I mean, it's complex. So maybe you can Google a bit and get some papers. I mean, we're very open about how the technology works. So there's some academic papers and other information about how it works. But as a sort of takeaway, I would say it's really a combination of old and new ideas. So we do add noise, which is a very old idea. It's a 40-year-old idea. We do suppress answers that don't have enough users in them, which is another old idea. This top and bottom coding, this is actually a phrase that means you kind of take the outliers and reduce them or increase them a little bit so they look a little bit more like the rest of the data, and so on. So there's a lot of what I referred to earlier as kind of ad hoc techniques are brought to bear on a query by query basis in the system. But there's some new technologies as well, which we call layered sticky noise, which I won't try to explain in the brief time I have, but it's a new way of adding noise that prevents, for instance, averaging attacks, that differential privacy, for instance, which is also a noise adding technique, would be subject to if you didn't limit the number of queries that people make. So it's this layered sticky noise that really lets us have as many queries as one wishes. You can't talk about this stuff, of course, without asking the question, well, how do you know it's anonymous? Who says it's anonymous? Questions like that, and we have these questions ourselves, right? It's a complex technology. Why do we really think it's anonymous? So naturally, we work on a lot of as best we can to find potential attacks and weaknesses in the system. But you cannot just go to a data protection authority in some country and say, certify this as anonymous, because these certification programs don't exist. In essence, because the technology is so complex, people don't really know how to do this. So kind of the approach we take is one of full transparency, and primarily one of encouraging people to attack the system. So we run a bounty program on anonymity with our system. So we allow people to attack it. We pay them if they succeed. We have a measure of anonymity that we can apply so that we know how much to pay people. And this is the approach we take in general, this approach of transparency and this approach of encouraging people to attack the system, so that we can be as sure as possible, never 100% sure, but you never are, but as sure as possible that the system is strongly anonymous, or if there are weaknesses at all, that we understand how they play out. So that's, I wish I could say more, but that's really all I have. The screenshot here is just a screenshot of our user interface. We provide an API that people can use programmatically to access our system, and it works with things like I forget the name of the the business intelligence tool that Tableau, for instance, or other business intelligence tool. This is a screenshot of our own interface, which shows that it looks very much like an SQL client. You can see the columns and the column types. You can type in SQL, you get back the answers. You can do simple graphs and so on. Anyway, here are some URLs. If you're interested, feel free to get back in touch with me. There's lots of documentation on the internet, Google for diffix, and you'll find most of it. And that's all I have. So thank you very, very much.
Thank you very much, Paul. I'm going to share my screen. All right. Thank you very much again. It's very important to talk about this issue of anonymity. Thank you for providing us with the difference between pseudonymity and anonymity. We really must ensure that the data we gather are still secure and provide anonymity to the people, and that we do not let any third parties to violate the privacy of people. I would like to also, we have some time left, so I would like to ask anybody from our participants if they would like to ask any questions. Please feel free to do so. We have a question panel in the GoToWebinar, and you can also raise your hand, and I can actually give you the floor. I can unmute you, and you can speak out loud to us, and then comment or have a question to our speakers. I would also like to ask our speakers if they have any comments on each other and they would like to say something more on the topic. If not, I would like to also say that we have a social media where you can find any other news or our activities that ABIS is doing. We can also if you think of the question about today's webinar, Anonymity of Open Data, later, we can talk about it at our LinkedIn group, ABIS Digitalization, where our speakers are as well present. So you can address anything there, and we can continue the conversation there. We will have the next activity is our ABIS Knowledge into Action Forum, which is going to be happening in London in May. So we are really looking forward to see everybody there. And I will make sure that the recording of the webinar is available and sent to you by email, all of our participants, all of our registered that couldn't make it today, and everybody in our network. I would like to therefore thank our speakers mainly for their terrific presentations, for their great performance and the time that you devoted to it. Thank you very much.
Thank you very much, Katerina.
Thank you, Katerina.
Thank you. And I would also like to thank our participants for their time. And so if there isn't anything that you would like to share, I think we can end this webinar, and you can have a nice weekend. Thank you, and bye-bye.
Thank you. Bye.